The input is 155. We want a run rate that produces a score which is strictly greater than the input. So if we use normal division, we obtain a decimal value which is not ideal for our purpose. Hence, we use the floor operator, and since our goal is to ensure that resulting score is greater than the input, we increase the run rate by 1. Calculate the total sum of the array. We need to remove exactly one element so that the remaining sum becomes even. Let new sum equals total minus removed element. Case 1. Total sum is even. Even minus even equals even. Even minus odd equals odd. Therefore, we must remove an even element. Check if the array contains at least one even element or not. Case 2. Total sum is odd. Odd minus odd equals even. Odd minus even equals odd. Therefore, we must remove an odd element. Check if the array contains at least one odd element or not. Functions used. Sum bracket A calculates the total sum of the array. Any condition for x in A returns true if at least one element satisfies the condition. Final logic. If total is even, it prints yes if any even element exists, otherwise no. If total is odd, it prints yes if any odd element exists, otherwise no. Key observation: to make total minus x even, x must have the same parity odd slash even as total. Two numbers can merge only when ai and aj equals to 0. Such numbers have no common set bits. A bit can never be shared by two elements that eventually merge together. Therefore, every bit position must appear in at most one array element. Count occurrences of each bit is from 0 to 29. If any bit count exceeds 1, it equals to no. Otherwise, it equals yes. What is a good string? A string is good if it does not contain three consecutive equal characters. Example: AABC is good, AABBB is not good. For each test case, first, traverse the string. Second, find length of each consecutive block. Third, add block length divided by 3 to the answer. And fourth, print that answer. You are looking for number of arrays of size n, where elements are numbers made of k bits that will become completely filled with zeros after you repeat a specific XOR operation 2k times. Find the number of independent chains. G. Calculate how many factors of 2 are shared between n and 2k. Let this be G. Find the length of each chain. M. Divide the total array size by the number of chains. M equals to n by G. If the chain length M is a multiple of 3, every chain gives you 4 configuration choices per bit. Your total answer is 4 raised to the power G raised to the power K mod 998244353. If the chain length M is a multiple of 3, the cycle crash and the only valid starting array is all zeros. Your answer is simply 1. We are doing all this because simulating the actual problem is impossible. If you try to simulate the XOR operations 2k times on an array of size 10 raised to the power g, your code would take years to run and instantly crash.